Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, today's lesson is about another subtopic of the first chapter, Algebra, binomial expansion. Let's have a look at the formula given. The formula given here are provided in the formula list during the exam. The one above here is the AS formula. The one at the bottom here is the A2 formula. Basically, both the formula are about the same. The only difference is the power n. The power n for the AS is a positive integer, whereas the power n for the A2 formula is a rational number. Alright, so for now, let's focus on the A2's formula. For A2's formula, you notice that it's bracket 1 plus x power n. We must start with a 1 here. Whereas for the AS, it doesn't matter what's the number for the front one and the back one, as long as there are two terms, A plus B. But for the A2, you must start with a number 1. Let me highlight this. Okay, so according to the formula, it's equals to 1 plus nx plus n times n minus 1 over 2 factorial x squared, and so on. If you notice, the n here is the same as the NC1 here. And for n times n minus 1 over 2 factorial is the same as NC2. And this one, n times n minus 1, n minus 2 over 3 factorial is the same as the NC3. How they change it into that formula is actually through this one. NCR equals to n factorial over r factorial times n minus r factorial. But I'm not going to explain further on how they change the formula. One thing that you're going to take note for the new syllabus is here. Modulus x less than 1. What's the use of this? This is the range of the values of x such that the expansion is valid. I'll explain further on this by using the example later. Have a look at this example. Expand 1 minus 2x power negative 2 in ascending powers of x up to and including the term in x squared, which means we have to expand until the x squared term. And then state the range of x for which the expansion is valid. So there are two parts in this question. Let's start with the first part. We will need to expand 1 minus 2x power negative 2. So the first thing to take note is you must make sure that your binomial expansion starts with a number 1. And now let's refer to the formula. According to the formula, is equals to 1 plus nx. Our n is negative 2 and our x is changed to negative 2x. That's how we apply the formula. For the next term, it's n times n minus 1 over 2 factorial times x squared. So let's apply this. It's negative 2 times negative 3 over 2 factorial times negative 2x squared. Here's how we solve the binomial expansion. And then we just need to simplify it. It becomes 1 plus 4x plus 4x squared. Alright. As for the second part of this question, which is about the range of the x for which the expansion is valid, we will just need to apply this. Modulus x less than 1. Let's see how we apply this. Now, let's prepare a modulus with the inequality less than 1. And we will need to fill up the x. So instead of writing the x, our x is changed into negative 2x. Alright? So when we modulus the negative 2x, it becomes 2 modulus x less than 1, and hence the solution will be modulus x less than half. This is the range such that the expansion is valid. Alright, for now, let's try to apply what we have learned into solving a past year question of the year May-June 2017, 9709/33. According to the question, you are asked to expand 3 plus 2x power negative 3 in ascending powers of x up to and including the term in x squared, and you have to simplify the coefficients. Alright, so let's try to do it together. First of all, we have to make sure the constant is a number 1. But for here, it starts with a number 3. So what shall we do? We are supposed to factorize a 3 and make it into a 1. So it becomes 1 plus 2 over 3x. And the whole thing is to the power of negative 3. Which means the negative 3 have to be applied into here and here. Then we will get 3 power negative 3 and 1 plus 2 over 3x power negative 3. Please take note here. This is a common mistake made by the students. The 3 must have the power negative 3 because it was factorized from the bracket up here. Alright, let's proceed with the calculation. Alright, so 3 power negative 3, it becomes 1 over 27. And let's put a big bracket here. And now we can start to apply the formula. According to the formula, it's 1 plus nx. The n now is negative 3, and the x is 2 over 3x. For the next term, is n times n minus 1 over 2 factorial. So it becomes negative 3 times negative 4 over 2 factorial. According to the formula is x squared, and our x is now changed to 2 over 3x squared. And then you can close the bracket. The following step will be just simplifying the coefficients. So now let's simplify it. And then you just need to multiply the 1 over 27 into each of the terms. Alright, now let's check the answer. The answer is over here. It's exactly the same. That's how easy it is. Let me add in a question. If you are asked to find the range of x for which the expansion is valid, what should you do? For the expansion to be valid, remember, as stated in the formula, modulus x has to be less than 1. For this case, the x is changed to 2 over 3x. So let's change it. 2 over 3x here. And then the 2 over 3 can be taken out. It's left with modulus x less than 1. And hence the solution is modulus x less than 3 over 2. And this is a range for the expansion to be valid. Come, now let's try another question of the year 2018, May-June paper 9709/31. According to this question, part 1, you are asked to express the function in the partial fractions, which is what we have done in the previous lesson. For today, we'll focus in part 2. Hence, obtain the expansion of the function in ascending powers of x up to and including the term in x squared. Usually, binomial expansion is related to partial fraction. This you have to take note. So if your partial fraction is wrong, then it will link to a wrong answer in part 2. So now let's use the answer from the part 1 to do the part 2. The part 1's answer is given down here. Alright, let me jot down this. Okay, so in order to solve this question, the number 4 shall remain the same, and then for the next fraction 3 over x minus 1, we shall bring up the denominator and make it a power negative 1. The same goes to the next fraction, 3x plus 2 power negative 1. For this question, there are two expansions right here, which is this 3 times x minus 1 power negative 1, and the next one 3x plus 2 power negative 1. Let's try to expand for the first one. I shall do it with a different color. Let's change the color for this. Before we can start with the expansion, take note for the constant here. It's a negative 1, and we can only start expanding when the constant is a number 1. So which means now we need to factorize the number negative 1. So the one inside the bracket will be left with 1 minus x. And the power negative 1 shall apply to the whole thing. And hence, we will get this 3 multiplied with negative 1. And take note, for this negative 1, got to have the power negative 1 as well. And then multiply with 1 minus x power negative 1. And the next step, we will have negative 3 multiplied with 1 minus x power negative 1. And now we can start applying the formula. According to the formula, it's 1 plus nx. Our n now is a negative 1, and the x now is negative x. Okay, and the next term is n multiplied with n minus 1 over 2 factorial x squared. So it will become negative 1 multiplied with negative 2 over 2 factorial multiplied with negative x squared. And the final step is to simplify the coefficients. And here's our first expansion. Let's highlight this. Alright, for now let's proceed to the second expansion. We shall change another color for this. Alright, so for the second expansion, it's 3x plus 2 power negative 1. So same thing, the first thing to take note is about the constant. The constant here is the number 2. So as usual, we need to change it into a 1. So what we need to do now is to factorize the number 2. Then the 1 inside the bracket will be changed into 1 plus 3 over 2x power negative 1. But this power negative 1 will need to apply to the whole thing. And hence, we will get 2 power negative 1 multiplied with 1 plus 3 over 2x power negative 1. 2 power negative 1 is actually 1 over 2. And now we can start to apply the formula again. So it's 1 plus nx. The n is negative 1. The x is 3 over 2x. So the next term is n times n minus 1 over 2 factorial x squared. So it becomes negative 1 times negative 2 over 2 factorial times 3 over 2x squared. And the last step will be just the same. Simplify the coefficients. Then we will get half minus 3 over 4x and plus 9 over 8x squared. Let's highlight this as well. Alright, here comes our final step. Our final step is just to substitute these two expansions into here. Come, let's do that. So the final answer is 4 plus negative 3 minus 3x minus 3x squared minus the next expansion, which is half minus 3 over 4x plus 9 over 8x squared. Let's simplify this. And the final answer is half minus 9 over 4x, and the last term is minus 33 over 8x squared. Let's check for the final answer. Have a look here. Half minus 9 over 4x minus 33 over 8x squared is exactly the same. Alright, so this is how we solve for the binomial expansions problem. That's all for the lesson today. Thanks for watching.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.